we're going to be solving this problem by hand and also by using Python. Okay, so it's given to us that this is a binomial setting. Okay, let's read the problem and see how we're going to go about it. Asia's favorite cereal is running a promotion that says 1 in 4 boxes of the cereal contain a prize. Suppose that Asia is going to buy 5 boxes of the cereal and let X represent the number of prizes she wins in these boxes. Assume that these boxes represent a random sample and assume that prizes are independent between boxes. What is the probability that she wins at most one prize in the 5 boxes? Okay, so they give us the probability statement, which is the probability that X is less than or equal to 1. So in other words, the probability that the number of prizes she wins in these boxes is less than or equal to 1. Okay, so how do we figure this out? Well, we have two options. We could either do, we have three options. Do it like arithmetically or use our calculator and use binom PDF or binom CDF. Now, which one are we going to use? PDF or CDF? When we use PDF, that's when they want us to find the probability of something happening at an exact value. So it would look something like big X is equal to small x, okay? So that's when we use PDF, and we want to find a probability of something happening at an exact value. But in this case, we actually have X is equal to less than or equal to small x, in which this case small x is 1. So we're going to use CDF, okay? So it's going to end up being binom CDF. And for this, we want to remember that the format is NPX. So in other words, if we look at what our N is 5 boxes of cereal. So that's our number of trials. So how many times or how many chances do we have to earn a prize? That's going to be 5. So that's N is equal to 5. The probability of a success, because that's what we want to find, having a prize, winning a prize is a success. So what is the probability? Well, it says 1 in 4 boxes of cereal contain a prize. So it's going to be as a decimal 0.25. And then X is basically the value, the number of prizes that Asia wins. So we want to know what is the probability of it being less than or equal to 1. So when we put that into the calculator, that's going to give us 0.6328, but they want to round to the nearest hundredth, so that's going to end up being 0.63. And that is the probability that the number of prizes Asia wins being less than or equal to 1 is 0.63 or 63%. So there's a 63% probability that Asia will win less than or equal to 1, less than or 1 prize. Okay? So this is by hand. Okay, now we're going to do the same thing except using Python. So the first thing you want to do is you want to import, let's actually do from scipy.stats import binom. So what we're doing is we are importing the binom function, which stands for binomial, from the scipy stats package, okay? So let's run that, and that's going to do nothing because we're just importing it. But now we're going to use do binom dot CDF because again we're using CDF because we're working with less than or equal to, not finding a probability of an exact value. So we're going to do binom.cdf. Now if you remember, the format was NPX. So we had our number of trials, our probability, and then our X value. But in Python, it's actually different. It's actually XNP. So you're going to have your X, your N, and then your P. But what I like to do is I like to define my variables before. So again, our X, as we defined before, was 1. So we want to find the probability of the number of prizes that A earns is less than or equal to 1. So 1 is our X value. Then our P, again, 1 in 4 boxes of cereal contain a prize. So that's going to be our probability. As a decimal, it's 0.25. And what's the last one we need? Our N. Well, I did that backwards. Okay, our X and then our N. So what's our number of trials is 5. So now all I have to do is run that, and it's going to give me the answer that I desired, right? And because they want us to run our answer to the nearest hundredth, we're going to go ahead and apply the round function. So in the round function, all you have to do is apply what you want to round, which is the first parameter, and then in the second parameter, how many decimal places you want it to round to. I'm going to say 2 because that's the hundreds place, and now you're going to see it's going to be 0.63. And that's all you have to do to find the probability in a binomial setting using Python. So to conclude, the probability of Aya winning less than or less than or exactly one prize is 63%.